Sometimes I just like to have fun. Now, a while ago I did a video about how to pause jobs and even recover them in the event of a power failure, and I thought, how can we take that one step further and completely eliminate the risk of power cuts altogether? Well, I got a portable power station in and decided to do some experimenting. But before we go through the experiments, let me cover off what a power station actually is, because you don't see many in workshops. Now, in its simplest form, it is a very big intelligent battery, and you often see these in motorhomes, caravans, RVs, those type of things, for people to have power whilst off grid. Now, the unit in front of me here is the AFRI 2400 watt unit. Now, this is around $700. There are cheaper units down as low as $300 and even ones over $1,000. And the difference really in what you're paying for is the size of the capacity of the battery and the features on it. Now, on the surface, that may seem expensive for a battery, but you'll understand why it's important very shortly. Now, after doing my original recording, I'm very happy to say I've managed to get some exclusive discount codes from the company for you, the viewers. Now, there are some links in the description area that will take you to the Amazon site in order to purchase these, and the codes on screen are going to bring the price down. On Amazon.com, for example, I think it's going to bring the price down to $599. So definitely check those links out and use the discount code in order to get the extra discount on top. Now, in terms of the features on this particular unit, it can be charged from a wall, it can be charged from a solar panel. And in terms of taking the power out of it, well, you've got a variety of different options. You've got standard plug sockets on the side, we've got cigarette lighter sockets, we've got different USB ports with different power ratings. It runs AC, it runs DC, and when I say it's intelligent, well, it tracks everything live on screen. What is coming in, what is going out, and gives you an estimation of how many hours is remaining based on that current output. It can even be tracked from your phone. So even if this isn't in view, you can still see the live data going on your screen. Now, I've brought it in to do two experiments. Can we run an entire CNC machine and accessories off grid? And can we continue to run the CNC machine with a power cut? Now, inbuilt within these is a device that allows it to detect when power cuts out, and it should switch to the batteries almost instantly. And this is where it becomes better than a generator, because the switchover is less than 10 milliseconds, which means your computer and your CNC machine shouldn't know any difference and just continue to run. Now, when I said a couple of seconds ago about this may seem expensive for a big battery, this is where the peace of mind comes in. Knowing you have that stability, knowing you're not going to waste material on failed jobs, knowing your machine isn't going to get ruined from it crashing due to a power cut. So when you talk about it like that, that is where the value of these machines really come into play. Now, somebody may question, why would you want to run a CNC machine off grid? Well, obviously not one this size, but maybe more for those who go to things like craft fairs and want to do personalization on the spot. You can run a small CNC machine or maybe a laser, and ultimately it just gives you that freedom and flexibility to offer more there and then. But let me show you how it got on with the first experiment. So this is the experiment right here. We've got the Fox Alien XE Pro with the Makita router fitted. This is going to run via the offline controller, and it is all going to be powered by the unit over there. And this is the job I am going to be carving. This is Mount Rainier that I did a couple of years ago. I can't remember the exact time, but I know it was over 5 hours, so it should be more than long enough job to see how long this can actually last. Now, obviously I am doing it as a dry run, purely just to avoid damaging anything. So let's get that powered up, let's get the job started and see how long it can run for. So I clearly underestimated two big things there. The length of the job. I stopped that at 53% the way through, 4 hours and 40 minutes running. So that would have been a 9-hour job. The second thing was how long that unit has lasted. I thought we would get 2 to 3 hours out of it, maybe 4 hours at a push. But at the point we stopped it, there is 72% capacity remaining, and that could have continued running for another 16 hours at that rate. That is honestly brilliant. Now, there are a couple of things to factor in. Obviously, I wasn't actually cutting any material, and also there is no dust collection connected to it. Now, vacuums can be quite power consuming, so that would have brought the rate down even more. But still, we have had a lot of running out of that battery unit so far, and I'm genuinely really impressed. So after that job finished, I ran another one the next day, except this time I included everything. PC with 2 screens, the CNC machine, the router and the Fox Alien vacuum. Now this all ran for just under 40 minutes and it said there was 75% battery remaining, which should mean that in theory it can run for around 2.5 hours, maybe just a little bit more. So let's step it up another level. We've got the Shopsmith DC6000, which by the way is a brilliant dust extractor. Because I'm in the UK and it comes from North America, I have to run it through a step-up unit. We've got the PC itself, we've got the 1.5 kilowatt VFD spindle, and we've got the LongMill. Now the job says it's going to take about 2 hours and 20 minutes to do a big Darth Vader. So let's get this finished off, get it running, see if it completes it. Now the audio quality on this is probably not going to be great, but I wanted to explain in terms of drawing power from the power station. Now the biggest consumption is when everything fires up for the first time, when you turn the dust extractor on, when the spindle starts spinning, everything will spike. But then once it actually gets up to speed and starts running, it comes back down to a more consistent level. And that way should allow it to run for longer because say it's just on a plateau in how level everything is running in terms of its consumption. So that was actually quite an interesting experiment. I mean, the first thing is all those bits were not meant to come off the piece of art, so technically it is definitely a unique piece now. But actually the main thing was this finished in 2 hours and 20 minutes. There was 25% remaining on the power station. So that would suggest that all of this setup was using less power than the smaller setup that I was originally showing. Now I genuinely thought one of these bigger dust extractors would be drawing more power than the smaller vacuums. I don't know, clearly I'm wrong, maybe I should look at the specifications. Definitely interesting results from it. But now let's move on and mock up a power cut. So we're set up for experiment 3 now. I'll put a new piece of MDF on the bed. The power station is charging at the same time as supplying power to everything. It can do that because of its inbuilt features and being able to manage the power flow. Now what we're going to do is run the exact same job, let it get about a minute in, and then we're going to kill the power to it. And all being well, we shouldn't notice a thing. The GoPro is set up behind me, recording the screen on the actual power station itself, and we should see when the power cuts out and it switches over to output only. So let's get everything started, let's get the job running, and then let's simulate a power cut. Okay, so what didn't help that experiment was as I pulled the extension cord out, the GoPro fell over because I shook it. However, we could clearly still see that everything continued to run. There was no pauses, there was no glitches, there was no missing steps in the job itself. So it just goes to show how these units can switch their power input and output almost instantly, avoiding any interruption in jobs that you are doing. So when we are talking in power cut scenarios where it just goes out, it does mean that as long as you have everything running through that unit, you will not notice any impact at all, and it will continue to run till either a point that the job finishes, or you can pause it and make it safe until the power comes back on. But ultimately, it proved what I hoped, that this can run during a power cut. So 3 successful on-camera experiments, but off-camera I also run a few different devices, including my fibre laser, CO2 laser and my table saw. I wanted to see how a larger capacity motor dealt with the initial draw of power when it started up, and everything has ran flawlessly. Pretty much anything you can connect to these, they're going to be able to run. So if you are in a scenario where either you have power cuts or power surges, this might be the solution for you in order to minimize the amount of failures that you have. Now obviously, as I said earlier, I was kind of mid-range in the one that I've got, but even the smaller, cheaper units do the same thing, just with less outlets and a smaller battery capacity. So definitely something to look into, and of course I always put links down in the description area to anything that I'm showing on the channel. So if you've got any questions about it, do let me know in the comments section. But thank you all very much for watching, and final thanks as always goes to my patrons. I will see you all on the next episode.